Hi, my name is Ryan Navarro, and I'm an applications engineer at Hawk Ridge Systems. This is the second part of a two-part series on how to define 2.5-axis tapered pockets in CAMWorks. So in the first video, we looked at how to define a tapered pocket by using the auto detect feature when we're defining a pocket. And you could also do this by manually specifying the taper angle when you're going to define a pocket, and that results in CAMWorks tapering down the toolpath as you go down your pocket, so you can machine it even with something like a flat end mill. But next we want to take a look at, if you're machining these pockets frequently, you'll probably be using a tapered end mill. And in that situation, we want to define our pocket so that we don't taper it down like this. We don't want to double compensate for the fact that we have a tapered pocket. So we'll look at the procedure for defining a pocket when we want to use a tapered end mill. And the first thing I really want to do is measure the angle of my pocket, because I want to add the appropriate end mill to my tool crib. So I can measure the angle of the pocket by going to my Evaluate tab in SolidWorks, choosing my Measure tool, and then selecting an edge on the pocket wall. So let's see if I can select an edge there, and then also a reference face. And I can see that my angle between the two is 80 degrees. So I would expect that to be 90 degrees if it was a perfectly straight wall. So that means I have a 10-degree taper. Okay, so I have a 10-degree taper. So I want to add to my tool crib a 10-degree tapered end mill. So I'll double-click on my machine, go to my tool crib tab, and then go to Add Tool. And under our tool types, I have flat end tapered end mill here. And I'll just click OK to list out all my end mills. And I want to choose, in this case I'm looking over here where it says degrees. There's also a column that says taper angle. I'm looking for a 10 degree, and I'll choose the 1/4 inch 10 degree end mill. So now that's added to our tool crib. So once we define our pocket, we'll be able to use that tool. Okay. So now I want to go back to my CAMWorks feature tree and add a 2.5-axis feature for this pocket. Now, because I'm not trying to interpolate the step down for the ramp of the pocket, I want to uncheck taper, check for tapers and fillets. It doesn't really matter as long as I don't click auto detect or specify a taper angle. But just to be safe, I'll uncheck that. And then you need to think about whether you want to be defining the pocket by the bottom or the top edge. So in this case, I want to be applying by the bottom edges of this pocket. Okay, so I want to select the bottom loop, and I'll click Next. And then what I'll do is define that bottom loop up to my top face. Okay, so you'll see there's a gap there, and you might think, hey, let's apply the taper, but no, we want that gap because we want the tool to be driven across this loop that we're selecting here. And it's going to result in correctly cutting our geometry. Okay, so that looks good. We're going up to our face, but I also want to take care of these islands that we have in the middle. So if I click Finish right now, it'll try to auto-detect the islands, but I want to click Next so I can manually specify these islands. So I recommend manually specifying them instead of using the auto-detect when you have tapers, because you don't really know, how it's going to compensate with the auto-detect. So I'm going to click Add to add these islands, and I'll also select them based on their bottom loops. Okay, so I'll add both of those, click OK, and then we can see that they're also being kind of specified based on the bottom loop and pointing up. So I'll click Finish and Close, and now I have my feature created, so I'll generate my operation plan. And now I have a rough mill and a contour mill, but you can see with that strategy I'm using, they're using flat end mills. So I just want to double click them and go to my tool crib and choose that tapered end mill that I added to my tool crib. So I'll select that. We can see a preview of the tapered end mill there, and I'll click OK. And I'll do the same thing for my finishing operation here. My contour mill, I'll go to my tool crib and select my tapered end mill. And click OK. So now I can generate my tool path. Okay, and we can see that the tool path in this case is straight down, which is what we want when we're using the tapered end mill. When we're using a flat end mill to cut a tapered pocket, we want it to ramp down like this, But for our tapered endmills, we want to make sure it's straight. And I'll go ahead and simulate through this entire machining operation here, and we can see the auto detect pocket on the left versus the pocket with our tapered endmill on the right. And if we do show difference, we can see that using the tapered endmill, we're really accurately representing the pocket to a degree that you'd have to use really small step downs to achieve. So using the tapered endmills, you just want to remember to program, in this case based on the bottom loops of your pocket, and make sure that you're not double compensating by leaving on something like auto detect or specifying a taper angle in the software. So I hope these videos were helpful, and please check out our YouTube channel for other helpful CAMWorks and SOLIDWORKS videos. Thanks.